Hello friends, in this video we are going to see how to perform the backup and restore of etcd cluster. In the previous videos we have already seen how to set up an etcd cluster in Linux environment, and also we have seen how to upgrade an etcd cluster from a source version to a target version. In this video we are going to see how to perform the backup and restore of the etcd cluster. We have already discussed that in an etcd cluster, if we have n number of nodes, to have the normal operation, more than n-1 by 2 number of nodes should not be failed. That means if we have 5 node cluster, we should not have 2 nodes to be failed. So at least 3 nodes should be operational in a 5 node cluster. Similarly, for 3 node cluster, 3-1 by 2, that means more than 1 node should not be failed. But in case of some hardware failures, if more nodes are failed, so there will not be any consensus among the nodes of the cluster to decide which node is a leader or a follower. To overcome this, etcd provides the backup and restore approach to recover the cluster in case of any failures. Since the data is replicated among all nodes of the cluster, we can take the backup from one of the nodes, for example the leader node. Using that backup snapshot, we can restore other nodes. So this backup can be taken in two ways, either by using the native snapshots provided by etcd, or we can take the backups by using the volumes. For example, in case of AWS, we can use EBS volumes to take the backups. So in this video, we are going to see the native snapshots approach provided by etcd. Let us discuss this in the demo. Let us start. Let us start with taking a snapshot of the cluster. We have already set up a 3-node cluster in the previous video. Please go through the link in the description section for setting up a cluster with TLS. Here we have 3 members of the cluster, etcd node 1, node 2 and node 3. So before taking the snapshot, let us identify which is the leader in the cluster so that we can take a snapshot in the leader node and then we can distribute the snapshot to other 2 nodes. Since we have established TLS, we need to identify the location of the certificates where we have stored. I have stored the certificates and corresponding key under etc SSL directory. So let us write the command for taking a snapshot. Here I am using the version 3 of etcdctl API. Here we are using etcdctl command. We need to mention all the endpoints. So these are the endpoints. This is for node 1, node 2 and node 3. So now we need to provide the certificate information. First the CA certificate and then the etcd server certificate which is signed by the CA and corresponding private key. To know the leader member, we can use endpoint status. This is the output of the command. Let us write it in a table. Here we can see there is a column is leader. So this indicates for the first node it is true. That means the etcd member in this node is a leader. So let us take the snapshot in this node. Let us create a backup directory where we store the snapshots. So this is the directory in which we store the backups. So now let us take the snapshot. So for that we'll use the same etcdctl command with the same options. Here for the endpoints, I'll use the endpoint of this node only. Then we need to provide snapshot subcommand. For this we need to provide save option. And finally the location of the backup where we store the snapshot. So here I am giving the name as etcd snapshot 1. So generally in the production environments, we take the backups or snapshots at regular intervals of time and the naming convention would be with the corresponding timestamp. So let's execute this. So here we can see that the snapshot is saved at this location. If we want to restore the cluster using this snapshot, then we need to distribute this snapshot to other nodes as well. So let us transfer this file to other 2 nodes as well. So now we have transferred the snapshot to other 2 nodes as well. We have taken the backup with root user. Generally, we should take the backups with the same user with which we run the etcd cluster. Here it is etcd user. So let us change the ownership to etcd user on the snapshot directly. So this command we have run in node 1. Similarly in node 2, we need to provide the ownership to etcd user on the snapshot which we transferred. Before restoring the cluster using the snapshot, let us verify the status of the snapshot. For this, we can use etcdctl command, or in the latest version of etcd, we also get etcdutil command. So we can use etcdutil command as well for knowing the status. So let us use that. So here we need to provide status and then the snapshot file location, and we can write the output to a table. Here we can see the revision and the total number of keys as 10. So before restoring the cluster, let us put some example data. So I am using the same etcdctl command. For this I am giving put subcommand. Here I provide the name as after snapshot. So this is the name of the key and value is testing. Now we have put in new data. So let us get this data. So we have this key after snapshot in the cluster. So when we restore the cluster using the snapshot, since this data is put after the snapshot, we should not have this data in the cluster. So that we will verify after restoring the cluster with this snapshot. Now let us restore the cluster. For that, let us create a directory first. This is the directory which will store the data of the restored cluster. We need to provide the ownership to etcd user on this directory. Let us execute the same commands in other two nodes as well. This is the official praise provided by etcd. Here various disaster recovery strategies are explained. Here it is mentioned about the restoring a cluster. So basically while restoring the cluster, we will assign the new names for each of the etcd members which are going to be restored. Here we can use this command. So we will restore with etcd user. Here I will execute the command with etcd user, and here we are executing etcd util command and then snapshot subcommand. For that we are giving restore option. So here we need to provide the location of the snapshot. In the node 1, this is the location of the snapshot. Let me copy this. Here we can provide the new name for the member 1, etcd n1. Here we will mention all the members of the cluster. Let us copy this from existing cluster. For that I will check the service. So this is the environment file where we provide all the environment variables about the cluster. So let us copy this one. So for first node the name is etcd n1, for second node it is n2, and third node is n3. The cluster token is etcd cluster. We will keep the same name. So for this we need to provide the URL of the first node. Similarly, we need to create commands for second and third node as well. So in the second node, this is the location of snapshot which we copied, and the name would be etcd n2. Similarly for the third node, this is the location of snapshot and the name would be etcd n3. This is 41 and here 42. So in these commands, we also need to provide the data directory, and we need to provide the latest directory which we created. Let us copy the same to other two nodes as well. We can execute this command in node 1 now. The command is executed, and here we can see it has restored the snapshot in this new directory. Now we can execute other two commands in the second and third nodes respectively. Here also it has restored the snapshot. In third node also it has restored the snapshot. So we should note that before restoring the snapshot, we need to make sure the client should not access the cluster. For example, in case of Kubernetes, the API server should not access the etcd cluster. Now we have the restored data, and we need to change the application environment configuration to use this new data. Before that, let us stop the etcd servers in all the nodes. The server is stopped in all the nodes. Now let us update the environment variables. So here for the name we need to provide etcd n1, and for the data directory it should be etcd new, and for the initial cluster also we need to change the names. Let us change in other two nodes as well. So here the name would be etcd n2, the data should point to etcd new, and here we need to update the members n1, n2 and n3. Similarly for third node, now we have changed the etcd configuration in all the three nodes. Let us save these configurations and start etcd in all the nodes. the configuration is changed and the servers are started in all the nodes. Let us verify the list of members. So here we can see these are the names of the new members: HCD N1, HCD N2 and HCD N3, and these are the corresponding client addresses. Now let us check the endpoint status. So these are the endpoints. Here we can see a column called is leader. This is true for the member 1 and this is false for other two members. That means the member 1 is the leader and other two are followers. We can verify the keys which are present in the cluster. So these were the keys I have put earlier. That means the data is restored successfully. And also we can verify the other key which we put after the snapshot is taken. For this we did not get any value which is expected, because this key we have put after the snapshot is taken. This is about how we perform the backup and restore of HCD cluster in general. I would explain the backup and restore of HCD in a Kubernetes cluster in the next video. I hope this video helps. Thanks a lot for watching.